Okay, when you unpack your dPC unit, you have the fractionator itself, the power supply, two different sets of power leads, a short one and a longer one, power cords for the power supply, a power cord for the fractionator, and an RS-232 cable to link the two together. We will be using the short leads today. The longer leads are here should you wish to place the power supply on a shelf behind the unit or next to the unit. If you're going to stack the fractionator on top of the power supply, align the front of the unit with the front of the power supply. You'll notice that it hangs a little bit over the back. So once the fractionator is stacked on top of the power supply, I'll connect the RS-232 cable connecting the power supply to the dPC unit. The male side goes to the dPC, and the female side goes to the power supply. There are electrical lead-ins in the back of the unit should you wish to have the power supply feed into the back of the unit. We will not be using these today. So I will now go ahead and put in the power cords. I'm now going to use the short leads to connect the fractionator to the power supply. Red, of course, goes to the red side. Black goes to the black side. You want to be sure that they're pushed all the way in to ensure good contact. Now that you've set up your unit, you're ready to start. Turn on the power supply, followed by the fractionator. Fractionator will rock back and forth briefly, and will be downloading programs through the RS-232 cable into the power supply. This is a temperature indicator which indicates the temperature of the fractionation area. You're now ready to begin your experiments.
You're good.
Now that we've set up the instrument, we're ready to get started with our experiment. Today I'm going to show you the protein fractionation kit. Here's one for the pH range of 4.20 to 6.20. All kits are set up exactly the same. They contain a quick start guide, 6 dPC chips, and storage buffer, each one individually marked with a number, serial number. It comes with urea, thiourea, ready for resuspension. You add 10.5 mils of 18 mega ohm water to this to dissolve. Comes with the anode and cathode buffers and a vial of DTT. In addition to that, we provide an empty vial for you to pipette the DTT into this, so should you have any left over, and for convenience in pipetting. We also supply a little bit more detailed quick start guides, one on running the procedure itself, the other on how to put the running chambers together, and of course when your instrument ships you have a very detailed user's guide which has everything from instrument setup to running the fractionator as well as using the plug harvester. First step is to equilibrate the chips in distilled water. So I have two 50 ml conical tubes, and I'm now going to remove the chip from the pouch by tearing off the top. I'm handling only by this bent handle part, not touching the plugs, and I'll simply drop it into a tube with water. I'll do it with a second chip as well. Again, not touching the plugs. These will sit in distilled water for at least half an hour. It can go longer than that, but it should be at least half an hour. In the meantime, I've resuspended my urea thiourea in 10.5 mLs of distilled water. I'm going to give that at least an hour, preferably 2 hours to dissolve. This can also be done the night before or weeks before. It's quite stable. Okay, we've now prepared the buffers according to the instructions on the Quick Start Guide. And because we're using a 4.2 to 6.2 pH range, we're going to add the sample to the cathode buffer. One thing to note is that when you pipette your urea thiourea, you want to be sure to give it a minute or two for the ion exchange beads to settle to the bottom. You want to avoid pipetting those into your buffer sample. I will now pipette my sample, which is a cell lysate, into my cathode buffer.